All right, so today being the 9th of July, hopefully you all had a good break. I had my grandchildren visit from Minnesota, so that was good. Yeah, and it was so crazy though, because we were going to the fireworks, right? But we didn't want to actually go to the park downtown because it'd be too crowded, so we thought, well, we'll go somewhere else. So we were walking up to Copeland just to see how that would work, and there were like 5 different collections of fireworks all going off at the same time. This was like, Corridor 10. And I'm like, where are these people getting all these fireworks? And do they have permission to do this? And I don't even know, but there was just tons of them going off. So it was fine. But then when you get to Copeland, you can't see very well. So then if you want to go look at the fireworks, don't go to Copeland because it's just too far away. And the trees get in the way. All right, so now you know. So today then we're going to talk about more hypothesis testing. And we'll do that for the first hour, and then the second hour we'll have exam number 5. And just a note that I did not put this equation on the practice test, but I should have because it is given to you on the actual test. So when you ask what's the test value, I'll give you the formula so you can just put the numbers in. All right, so does anybody have any question about anything on test 5 before we move on to the new stuff? Okay, so I guess we'll move on to the new stuff. A little bit though, before we actually get into the new stuff, I want to talk about some of the connections that we need to make with what we had previously, because specifically, when we ask the question, confidence interval versus hypothesis testing. Are both of these supposed to give us information about the population? Okay, that's my question. Are both of these designed to give me information about the population?
Yes.
Yes, they are. They're both designed to go from sample information to give me information about the population, both of them. Which one of them gives me more information than the other one does? Why would you say that?
Either really good or really bad at guessing.
Yes, that's correct. You are not giving me the correct answer, you're giving me the incorrect answer. Okay, so that means in this particular example, you're bad. I'm saying, okay, so no. Hypothesis testing does not give me more information. Confidence intervals give me more information. Why would I say such a thing? Because a confidence interval, what's the purpose of a confidence interval?
Population.
And so what we get when we do a confidence interval is we have an interval. and we know where the measurement of the population actually is based on our sample. We get an interval. What is the purpose of hypothesis testing? Okay, the purpose of hypothesis testing is to prove a difference. And so the answer to the question when we get done with hypothesis testing will be, yes, there is a difference, or I don't know if there's a difference or not. So all we get from hypothesis testing is a statement about there is some kind of difference. But with a confidence interval, we're actually getting numbers that tell us what the population is. In hypothesis testing, we don't. Okay? So generally, when we look at confidence intervals, we would say that they are perhaps a better way to go. However, there is an issue here when we do something. Okay? Let's just do an example. Let's say that I'm going to do a hypothesis test of the proportion, and let's say that I'm talking about 60 out of 300. Okay. So I'm going to do a hypothesis test, and I think I'll mute this so that we don't have it staring at us. Let's just say I have situations where I'm asking a question like, how many people watched soccer? Okay, so how many of you actually watched the highlights of the Women's World Cup? Soccer. 2 out of 35 is not very high. So let's pretend that we were talking to people who are on a soccer team. And so then we say, P hat is equal to 1%. And let's say that we're asking the question, is this less than a national measure of whoops. And we're going to pick alpha is equal to 0.10. Okay. So yeah. I don't want to burn you out, okay, before the test, but yeah, I would like to know how am I going to do this? So what that means is everybody should have in front of them certain information that you're going to use to do something like this. Can somebody tell me what sheets of paper you should have in front of you right now? Steps for hypothesis testing and table F. Okay. Now this is how it goes. Everybody should have the steps for hypothesis testing and table F in front of them from now on. Okay? Anybody need steps? We all have steps? Jordan would like steps. All right. That's going to mean I have one here. Oh, sorry.
Thank you.
Everybody got table F? All right. So I want to know the null and alternative hypotheses. Emily, can you tell me null and alternative hypotheses for this situation?
Pass.
Okay. Casey, can you tell me null and alternative hypotheses?
No.
Okay. Kayla, can you tell me null and alternative hypotheses? All right. I want somebody to tell me null and alternative hypotheses. Gabrielle?
Your null hypothesis would be P equals 0.24,
Okay.
and your alternative is P is less than 2.4.
0.24, yes.
Or, yeah.
Okay. So that's the first thing. And according to the textbook, we need to identify the claim. But what we're going to say is, all I know here is that I can prove something to be less than. I cannot prove it to be equal to. And so we're claiming less than. All right? So now we need critical value and rejection region. Who can tell me critical value and rejection region here? Abby?
Would be negative 1.282.
It is. Negative 1.282 because it's a left tail test. And the rejection region would be anything below that. Alpha is 0.10, one tail test. All right. Test value comes out to be negative 1.62. All right, so who can tell me what needs to happen next? Okay, we need to decide whether to reject or not reject what? The null hypothesis. Okay. So, Hillary, can you tell me what I should do? Okay. Liz Thomas, can you tell me what to do? Okay. Mariah?
So we'd have to plot the negative 1.62.
Okay, and where is it?
I want to say it's like before the rejection.
Okay, I'm going to ask the question, is it to the left or to the right?
To the left.
It is to the left of this. So it's over here. Okay, so far, so what does that tell me, Mariah?
We would not reject it. Unless it's technically in there and that should be.
Okay, this technically goes out forever.
Okay, so we would reject it.
Okay, but the word it is banished from our conversation. We do not use the word it. We say reject, and then we fill in that blank. Reject what? The null hypothesis. We do not say reject it, because that doesn't tell me what it means. We say we reject the null hypothesis. Okay? We reject the null hypothesis because the test value is in the rejection region. All right? Caitlin, can you tell me what happens when I reject the null hypothesis? Okay. Mattia, can you tell me what happens when I reject the null hypothesis? Okay, we proved a difference. All right, so I want a little bit more words having to do with that. Abby, can you tell me what my extra words that I want? I'm sorry? A decision can be made, that's correct. No, that's wrong. And of course, if you get all the way down to the problem and you say the wrong answer, that's really wrong. Because there's two options here, and if you do the wrong one, it's really wrong because there's only two options. Okay? Liz Stanish, can you tell me what to put in here? Okay. Mara? All right. Can anybody tell me what I want? Okay, there is evidence. No. What am I trying to prove? Am I trying to prove the null? What am I trying to prove? The alternative hypothesis. When we get down to the end and we reject the null hypothesis, then we say there is evidence to prove the alternative hypothesis. We cannot prove the null hypothesis. We can only prove the alternative. If we reject the null, we prove the alternative. What are the other things that we should say at this point? There is evidence to prove the alternative hypothesis. Can someone tell me what else I should say? In your notes, when I told you there are two options, one of them happens when we do not reject, the other happens when we do reject the null hypothesis. So in your notes, you should have written down there, what are the statements that need to be said when we reject the null hypothesis? So what else am I going to say when I reject the null hypothesis?
Evidence for the difference between the proportion
Okay, so I'm going to not just say prove the H1 here, but I'm going to be able to prove what specific difference.
the population proportion and the standard.
The population proportion of what? What am I measuring? I'm measuring people who watch soccer. What do I say about people watching soccer? Okay, there is enough evidence to prove that this population proportion is less than the national measurement, which is 24%. When we say that we prove the alternative hypothesis, then what needs to happen is that you take that information and you say, I'm going to use the statement of the problem to describe this alternative hypothesis. So I'm going to say, yes, there is evidence that the proportion of people is less than the national number that we have. Okay? So when I get down to the end, this is correct. Okay? But I also want to put it in terms of the actual measurements that I've been doing. So there is evidence to prove that the population proportion is less than the national number. Okay. And you were aiming at that when you said we're proving a difference. Yes, that's correct. We're proving a difference. What difference are we proving? We are proving that the population proportion is less than the national number of 24%. All right. So when I ask that question on the test, hopefully you'll be able to relate to this clearly. What if I had said, do not reject the null hypothesis? Okay, if I say, do not reject the null hypothesis, then I'm going to say no decision. What else am I going to say?
Could be random variation.
Okay, it could be a random fluctuation. What am I going to say about the evidence?
There is not sufficient.
Okay, there is not sufficient, there's not enough evidence. For what?
Prove that the population proportion of people who watch soccer is less than the national number.
Correct. If I were to say that I do not reject the null hypothesis, I am not able to prove that it is less. It is less. 20 is less than 24. But if I do not reject the null hypothesis, there's not enough evidence to prove that the population number is less than 24. The sample number is, but I don't know about the population number when I say do not reject the null hypothesis. All right. So I'm glad we've had this little conversation today to be able to say what happens at the end of hypothesis testing. We have two things: reject the null hypothesis, do not reject the null hypothesis. If we reject the null hypothesis, then there is evidence to prove the alternative. And then we say what that means. There is evidence to prove that the population proportion is less than this national number. If we do not reject the null hypothesis, we're not able to make a decision because there's not enough evidence to prove the alternative hypothesis. We can't prove it. And so then we say there's not enough evidence to show that the population proportion is less than 24. The sample is, but I don't know about the population right now. Okay. Now, what would happen if I changed my alpha? What would happen if I made alpha 0.05 instead of 0.10? Rachel, can you tell me what happens if I change that to 0.05? Okay, Hunter, can you tell me what happens if I change it to 0.05? Okay. Emily?
We can't reject it then?
What is the number that goes here?
It's G negative 1.645.
It is. Now, can you repeat your answer with perhaps a little more detail?
The test value would be outside of the rejection zone, so we could not reject the null hypothesis.
That's correct. Okay, so then we would say no decision. This could just be a random fluctuation. There's not enough evidence to prove what we were trying to prove. So what happens in this situation is that the answer, the big answer at the end of the problem will change depending on what we choose for alpha. If I pick alpha as 0.1, then I make a decision. If I choose alpha as 0.05, then I don't make a decision. So then we're looking at this and we're saying, well, which one am I supposed to choose? Well, who knows, right? There's no set rule that says 0.05 is some kind of magical thing. It's not. There's no magic here. So then if we say, is it or isn't it? The answer is kind of. Because the alpha that we have is going to change our answer. And it depends on how much chance we're going to take of making an error. So then, let's look at the confidence interval. I'm going to do a 95% confidence interval for the proportion. And what I'm going to get, if I go with 0.05, I'm going to get a confidence interval that P is between 15.5% and 24.5%. So then if I ask the question, is this thing, this group of people that I've measured, whoever they are, do they have a number less than 24%? When I look at this right here, I say I don't know. It could be less than 24%, but it could actually be 24.5%. It could be higher than 24%. So then when I use a confidence interval, once again, I'm not able to make a decision because it could be below or it could be above. But this is giving me more information than just reject them all or not reject them. There is evidence or there's not evidence. This is telling me where the actual population proportion is. Now, if I look at those numbers, then I say, wow, it sure does look like it's less than 24%, even though it's a little bit on that side. It looks like it's pretty far below. I mean, it's not completely below, but it's just right on the edge. So then confidence intervals will tell me more information about the situation. But once again, why would I use 95%? Why couldn't I use 93% or 97% or some other weird number? It's just tradition that I put 95% on there. So when we're looking at these things, we have to be careful that we're not saying, if I go through a hypothesis test, that I actually know what's going on. What we're saying is, when I do a hypothesis test, I have some evidence, but it's not 100%. And my conclusions depend on what I choose for alpha. So I'm not going to just go out there and say, oh yes, I know exactly what's happening. I don't, because it depends on what my alpha is. All right, so now that we've covered that, to a certain extent, this, and this, rid of that. Okay. So what we've been doing here is just with proportions. But it's also possible for us to do the same process for, let's see if I can do this, hypothesis testing. We can do proportion. We can also do the mean. And we can also do the standard deviation. What happens here looks a lot like what we had before, but there are some differences, of course. The main structure, though, the solving hypothesis testing, it's the same process. So let's consider something with the mean. Let's say that we're doing a national survey of hospital infection. And let's just say that we're getting 16.3 per week. And I have no idea how accurate this is, I'm just using numbers from above. So 16.3 per week as average. But we go with our hospital for our. We look at 10 random weeks. And we find the mean and the standard deviation of those things. And so the mean is 17.7, and the standard deviation is 1.8. Now we're going to do the same process as what we had previously, but now instead of comparing proportions, we're comparing averages. So once again, the fact is, I don't care about these these exact 10 things. I want to know, is my hospital have more infections on average compared to this national number? And so then the sample I got is more, it's 17.7. But is that enough? Is that sufficient to prove a difference here? So my null hypothesis is going to be mu equals 16.3. And the alternative will be mu is greater than 16.3. That's the standard number that I want to compare to here. And so when I do this, I'm changing the symbol, but the idea is certainly the same, right? So I'm looking at this in comparison to this national number. And so then I have my hypotheses, I've identified my claim. Is our hospital average higher than national? And I want to put population in here. So now, what's my next step? I need a critical value. What table am I going to use? Well, we're not going to use Z, we're going to use T. Proportion, we used Z, but now we're going to use T. So if I look on table F, where am I going to look for my critical value? Sierra, can you tell me where I'm going to look for my critical value? Where on table F?
Would you do the average would be 9?
I would say my degrees of freedom is 9.
So you go over 9, and then are we using alpha as 0.05?
We are, alpha is 0.05.
A little bit of 0.05 in there.
Okay, how many tails do we have? How do we know how many tails we have? What am I looking at to know my number of tails? What am I looking at to find my number of tails? I'm looking at the alternative hypothesis. The alternative hypothesis says greater than, so it's one tail to the right. Okay. And what's really good is that even when you guys don't answer the questions, I'm pretty sure you know the answers. And so that's good. Most of you, I guess. All right, so now I'm looking at a sample size of 10, so my degrees of freedom is 9. And if my alpha is 0.05, then it's 1.833. So my critical value is here at 1.8. And again, as I pointed out, these are tails, so it starts at 1.833, but then it goes on forever. All right. So what's my test value? My test value T is going to be x bar minus mu over S divided by square root n. And of course, I'd give you this on a test, and it's something where you have to be careful to figure out the bottom of the proportion, or the bottom of the fraction first. And then when we do this, we come up with, okay, I got to put in my right numbers here. X bar was 17.7. Standard deviation was 1.8. And my comparison is 16.3. So my test value should come out to be 2.46. So then what happens? Well, 2.46 is over here. It's in the rejection region. So I'm going to reject the null hypothesis. When I reject the null hypothesis, that tells me there is evidence to prove the alternative. And now I want to know, what does that actually mean? What is the meaning of that statement? There is evidence to prove the alternative. What does that tell me? Well, it tells me that there is a difference. So then for our hospital, the population average is greater than the national average. So if I look at my hospital and I say, okay, all the different weeks that I have out there, I don't just have 10 random ones, but my hospital's been doing this for a long time. So then if I look at the average, then I would say our hospital has more infections on average than what is the national number. Now, hopefully that would communicate something, right? So then it's like, something's going on here. This is happening and it's not good and we need to do something about it or whatever. As it turns out though, remember that when we use this thing, if we have a small sample size, we would have to have bell-shaped data, and we don't know that. So then that might be a problem. If we don't have bell-shaped data, we might have to do something else. But at least what we're doing here, just based on this, we're going to say, yes, we've proven that our hospital has a higher average rate of infection than everybody else out there. Okay. So our hospital has high amount of infection. But when we say higher amount, what we actually mean is that the population mean is higher. Okay. Now, once you go through and you're familiar with how hypothesis testing works, then it's not that much different to do this. You're looking at the same process. The only thing you're doing is you're changing the symbols so that they are averages, not proportions. Your test statistic has a little bit different formula, but it's not that much different. And it looks kind of the same. On the positive side, it's a right-tailed test. Those are positive numbers. On the left-hand side, it's negative. All right. Any question about that process right now? Okay. So then, what's the next thing that we need? We need hypothesis testing for the standard deviation. So, how does that work? It works the same way, basically. But things look different.
Can I rewind a minute? So you're saying that positive is one tail and negative is two tails?
No, positive is to the right, negative is to the left. That's what I meant to say. Whatever I said, I meant to say that. Okay. So what I want to do here then, I want this to be dealing with my standard deviation. Now, what does the standard deviation actually tell me? The standard deviation is defined to tell me something. The standard deviation is telling me the variation of the data. How much variation does this data have? Is it spread out a lot, or is it all kind of put together in a small amount? Okay, so what I want to do here then is I want to try to prove that my standard deviation here, which is 1.8, when I did my national survey of hospital infection, let's say that the standard deviation was 2.5. Oh, I got to change it. Let's say 3 instead of 2.5. Sorry, I'm going to change this to 3. 2.0. So our hospital standard deviation is 1.8. So it seems to me like my data set, my hospital, even though we have maybe more infections than other people do, it's within a smaller variation. So our hospital is consistent about the number of infections that they have. Instead of having way high and way low, they just stay in the middle. A little bit more, right? 1.8 versus 3.0. So then what am I trying to prove? I have my standard deviation, 3.0, and I want to prove that the actual population standard deviation is less than that. So is our hospital population standard deviation less than the national number? Because it came out 1.8, but the national number was 3.0. So let's take alpha as 0.05. I have my hypotheses, I have my claim. I need a critical value in rejection region, but I'm not looking at table F. I'm looking at table G for the chi-squared number. So what happens here? I'm looking at table G, and I want a left-tailed test. So that means I want this over on the left to be 0.05. But what happens with table G? When I look down at the bottom of table G, my little picture, it's only things to the right. So I can't use the table directly. What do I have to do? I have to do 1 minus that. So if I'm going to have a left-tailed test, left-tailed chi-squared, then I use 1 minus alpha. So I'm looking at the column 0.95. Degrees of freedom would be equal to 9. What do I see? Okay, I'm on table G. Emily, you got something for me there?
Would it be negative 3.325?
It's not, because on chi-squared, they're not negative or positive.
Right, so then.
So it's just the regular positive. Yeah. 0 is over here on the far side. And so it's 3.325. Degrees of freedom is 10, so this number here would be 10. So it's on this side.
You mean the degrees of freedom is 9?
Oh, sorry, 9. Thank you. Degrees of freedom is 9. So that means 9 would be in the middle of this. 3.35 is to the left. All right. Now I need a test value. What's my test value when I do tests for a standard deviation? It's a chi-squared number, and it's n minus 1 times s squared over sigma squared. So in this case, it's going to be 9 times 1.8 squared divided by 3 squared. So, Tina, you have that number? No. Okay, somebody give me that number. 9 multiplied by 1.8 squared divided by 3 squared. .24. 3.24 is this value here, and that is inside my rejection region. 3.24 is in the rejection region. So, Sierra, can you tell me what that means? We're going to reject the null hypothesis. The test value is in the rejection region, so we reject the null hypothesis. So then, is our hospital population standard deviation less than the national? The answer is yes. There is evidence. Because I rejected the null hypothesis. Yes.
We didn't make it the critical value.
Because with chi-squared, every number that we have out here is positive. So then when I look up numbers on the chi-square table, they are just what they are. Whereas with the t and z, they have 0 in the middle, so they have positive on the side and negative. For z and now, as it turns out, your textbook, when they do these problems, they like to use the variance instead of the standard deviation. So they will have, instead of this, they will have sigma squared is equal to 9, and sigma squared is less than 9. Maybe when they come out with a new edition, they'll change that. But maybe not. Statistics people are weird that way, that if they love the variance, they want to express their love. And so then they put it into their hypothesis testing. So instead of doing hypothesis testing for the standard deviation, sometimes they write it using sigma squared, but it's no different. It doesn't change the problem at all. It just is, it's written differently, because we're using the square. Now, obviously, when you get over to this formula, you can see that we're squaring them. Well, that's fine. But why would we have to put it here? I don't know. That's just the thing. And again, when we're doing a left-tailed hypothesis test with chi-squared, it's still a positive number, and we're trying to figure out if our thing is between 0 and that number. That's the rejection rate. On the right-hand side, it's pretty much like we had. If it's greater than that number, positive, then it would be in the rejection rate. All right. Now, again, the concept here is that there's some kind of a standard number that we're given, and we're trying to prove if our situation is different. Does my hospital have more infections? Do people in La Crosse spend more money on lawn care than other people? Do children in La Crosse have higher sodium levels than children in some other national survey? So there's some kind of a number, and then we're trying to prove if our group, either on average or on a standard deviation, is different from something else that we were given. All right, so we're going to call it good right there. And then we're going to take a break for 10 minutes or so. And then come back and have test number 5.
the tables included
Yes,
with?
they-
Okay.
Mhm.
So I'll be here Thursday on the 3rd.
Okay.
Okay, thank you.
Sure. Oh, I better turn my thing on. Never mind.